In this video, we are going to learn how to write definite integrals as limit of a Riemann sum. So far, we have observed that when we use left or right Riemann sum to find area under the curve on a certain number of subintervals, it always gives us the either underestimation or overestimation, but not the exact area. To overcome this problem, what we do, we divide the area into infinite number of rectangles. And in that case, we use this formal definition of definite integral. Here n represent the number of subintervals which approaches to infinity. That means we use infinite number of subintervals. Let us see how to rewrite the definite integral as limit of a Riemann sum. Here the dx represent width of each rectangle, which is given as b minus a over n, and this gives us the x value. This would be written in terms of xi, because I is the variable which represent the number of rectangles. So let us see how it works step by step. We need to memorize two small formulas for that. One is, this is actually the width of each rectangle. The second formula is for xi. Now let us see how to apply this definition on an example. Here first we find the function, then we write it in form of xi. Step 1 is to find the width of each interval. Here this value, the lower limit represent the a value and the upper limit represent the b value. So a is 1, b is 3, and the width of each interval dx is, then step 2 is using this formula. It's a is 1 plus 2i over, and then we plug in this xi, and then we plug in the value of xi into the given function, which is 4xi square plus 2. Then we plug in this value over here. This is the last step 4, where we write the definite integral using the limit of Riemann sum. Plug in the values into this expression. We have already got the expression for f of xi. Let us plug in that here. This all was the expression for f of xi, and then we write the expression for dx, which is, so this is how we write the given definite integral using the limit of Riemann sum.